In this video, we'll talk about complex numbers and the basic operations we can perform on them. So what's the point of complex numbers, and what are they and what do they do? So we know that the polynomial x squared plus 1 has no real roots. This is sort of just the main fact we have from basic algebra. If I draw the graph sits entirely above the x-axis, so it has no solutions to x squared plus 1 equals 0. Those solutions don't exist. But what if they did exist? What does that mean? Well, if they exist, then we know that a solution x to this equation must satisfy x squared equals -1, or x is positive or negative square root of -1. And again, since only positive numbers can be squares, we know this has no real solutions. So the idea of complex numbers is let's make one up and see what we can do with the fact that once we have the solution exist, what else can we do with it? What we're going to do is we're going to define the imaginary unit I as the square root of -1. This is not a real number, so it's not a number in the same sense that we had numbers before as real numbers, but it's a different object we're going to define and see where that gets in terms of what can we do with this fact once we have this I exists. In that case, the solutions to x squared plus 1 equals 0 are plus or minus I. You can also simplify any square root you want with a minus sign in it using this I as well. For instance, square root of -16 is square root of -1 times square root of 16, because that's how square roots work. You can split square roots over factors like that. The -1 square root becomes an I, and the 16 becomes a 4, which means this equals 4I. So any square root you want with a negative number can be simplified using an I. And the main thing I might just mind first for what we can do with this is solve quadratic equations, because the main reason we had negative square roots coming up was when we were trying to solve quadratics with a negative discriminant. And so this now lets us also find factors in terms of these imaginary units for quadratic equations that didn't have them before. So now let's put a little more setup into our system and how we're actually going to talk about these imaginary units. So our definition for a complex number is the following. We'll generally use z to talk about complex numbers. And when we do so, we'll have z equaling x plus iy, where x and y real numbers. This I here is that imaginary unit we talked about before. It's a square root of -1. And so complex numbers have two parts. They have this x, which is the real part, because it's without the I, and the y is the imaginary part, because that's with the I in front of it. So for the number z equals x plus iy, we'll write x as the real part of z, with an re in front of it to note the real part, and y is the imaginary part of z. What do these numbers look like? Well, you could have something like 1 plus 3i. That's a complex number. The real part of that number is 1, because that's the part without the I on it, and the imaginary part is 3. It is the coefficient of I in this expression. Something like, look at something like the number w, which is another that we'll use for talking about complex numbers, as root 2 minus 1/3 I. Right, these are any real numbers. They don't have to be fractions. They can be square roots. They can be pi, e, things that can all show up as the real and imaginary parts of numbers. The real part of w is square root of 2, and the imaginary part of w is -1/3. These are the signs on that correspond to how they set up in the actual number themselves. Now I want to talk about operations on complex numbers. So it turns out all the operations we have on real numbers we can also do on complex numbers. Things like adding, subtracting, multiplying, dividing. Hit those first three here. The basic idea is you want to treat I like it's a variable in a polynomial, and then expand things out in group terms so that it matches the form of a complex number. Let's say I want to add two complex numbers together. I have the number a plus bi, and I have the complex number x plus yi, and I want to add these together. What I'm going to do is I'm going to drop all the parentheses, and I want to regroup so it's something plus something times I. And if I do that, I will get a plus x, which are the terms that don't have I on them, plus b plus y times I. And so that's how you add complex numbers. You basically just add the real parts, add the imaginary parts, that gives you your new sum. You can do the same thing for subtraction. So if I have a plus bi and then want to subtract x plus yi, it'll work the exact same way. I'll get a minus x plus b minus y I. Basically think about dropping the parentheses and rearranging terms so it looks like a complex number again. The one slightly trickier operation here is multiplication. And the key trick here is treating I like a variable and foiling this out to see what we get. If I FOIL this expression out, I'm going to get an ax for the first term. The second term is ax times bi. The third term is going to be an a times yi. And the last term is bi times yi. So I get ax plus xbi plus ayi plus by times I squared. But what's I squared? I squared is minus 1. Remember, I is the square root of minus 1. So this here becomes a minus 1, meaning I can bring that term to the front with the ax to give me an ax minus by, right, this term came over here, plus xb plus ay times I. And that's now in the right form of a complex number to think of as the product of these two complex numbers here. The reason why I define complex numbers in this way is because this works out so nicely. Because if I take the sum, the difference, the product, and we'll see in a second the quotient of complex numbers, I get another complex number. So this is the right sort of structure to build around these imaginary units to see what's going on. Right? If I just looked at just multiples of I, well, if I multiply two of those together, I don't get a multiple anymore. I get a real number because the I squared becomes minus 1 and I'm back in the real numbers. Setting it up this way means all the operations work nicely, because if I combine two complex numbers, I still get a complex number. And that's why we set things up in this appropriate way. Now for some examples, let's work out these here. So the first one is just simple subtraction of complex numbers. We have 2 plus 3i minus 5 minus 4i. So the first thing I'm going to do is sort of group the real and imaginary parts together. So we should see for the first part, we have a 2 for the first real, and then minus 5 for the second real part. And then plus a 3i plus 4i, which we're going to combine to give us our final answer for the first one as negative 3 plus 7i. For the second one, we first need to distribute our real numbers into the complex numbers. But multiplying a complex number by a real number doesn't change really much. If anything, you just multiply it inside like you're distributing. And so the first one, distributing 3 inside, becomes a 6 plus 3i. Distributing the 4 into the second one becomes a 16 minus 4i. And now I can add like I would normally for adding two complex numbers together. This gets me a 6 plus 16, and then plus a 3 minus 4 times I, or a 22 minus I. And then finally for the multiplication, we now just need to FOIL out this expression here, so then we can combine terms to get to what we want to do for the complex numbers. So we can FOIL this out. The first terms give me a 6, I get a plus 3i, I get a minus 4i, and then a minus 2i squared. The I squared becomes a minus 1, which means it becomes a plus 2 in the last term. We end up with a 6 plus 3i minus 4i plus 2. And regrouping gets me an 8 minus I for my answer here. There's basically a complex numbers and how you can add, subtract, multiply them to combine them to make new complex numbers. Right, the point here is, in order to make all this work nicely, especially the multiplication, we have to have these complex numbers being two parts, an x plus an iy, a real part and an imaginary part, where you've got, both of those could be any real numbers you want, and then together they make up complex numbers that allows all this to work out nicely to sort of combine them together. And we'll see in future videos about division and how this relates to the other calculus stuff we've been doing so far. And we'll see how all of this allows it all to be tied together nicely and have some things that we're sort of using make more sense and sort of reorganize our thoughts around these to make them easier to work with and discuss.